So my name is Christian. I work for Red Hat, Principal Middleware Specialist. I came from the consulting organization, so I've had a lot of hands-on experience with some of these technologies. In the consulting organization, I spent a lot of time at a particular client that is now well known, that point to that client, that company, because they are doing microservices right, and they're successful. So I got to spend a lot of time working closely with them. Oh, I thought someone raised their hand. Working closely with them and understanding, I got to see their technology. It was really cool. But some of the, nowadays when I travel to customers and talk to customers and I'm immediately asked about microservices, I kind of think back, so they're asking these questions, but there's a fundamental difference between where they are and where this one company was. Hopefully I don't slip up and say the name. Let's have beers later. But so a lot of what I'm going to be talking about right now is in a traditional enterprise, what is it that they're doing and what was it that this internet unicorn was doing and what's different? What are the challenges that traditional enterprises are going to face when they try to adopt microservices? I got a clicker. This is the question that I get asked. I walk in, we're talking with chief architects and directors and so on, and they see the hype. There's all these conferences and blogs and Twitter and everything. Will microservices help me? To me, the premise of the question is wrong. It's like let's just go get microservices and that's gonna help me. There's a little bit more that goes along with it, and every technology talk, where we're talking about new technology and new problems that we're solving, always starts off with the obligatory, well, businesses have to change, right? But and I'm gonna tell that story, but I'm gonna tell it from a little bit of a different twist, because why businesses have to change, and the way we look at how our businesses are structured and how we develop systems and teams and so on. That line of thinking is very, very important to how you go about developing a microservices strategy, because it's not something you just flick the switch on and decide that you're going to implement. I'll start off about 1880 or so. Let's start there. We got a lot of time to burn here. In 1880. A young guy named Tarek walks into, he's in the Middle East. He walks into a square. The government, oppressive government at the time, handing down some new changes or whatever, and he doesn't like it. So he gets into the town square, and he's this is bad. This is not good for us. We want change. So he's in there. He's agitating, and people start to form around, and the government can look and see what's going on here. Is this really a big threat to them? I mean, should they be worried about this one agitator? There's a handful of people in the crowd, maybe people passing through the square, passing through town. They don't know too much about him. They don't think he's aligned with their institutional enemies, but so they just let it go. They could go in at any time and squash it and whatever, but they just let it go. Nothing happens. You fast forward maybe 130 years, and a gentleman named Tarek walks into or is a streetcar vendor in Tunisia, and same sort of situation. The government oppressive, and they're bothering him, and taxes and all kinds of stuff that he's going to demonstrate against. And he ends up, the government knows everything about him. Everything on Facebook, on LinkedIn, on Twitter. They know where he eats. They know his friends. They know everything about him. Should they be worried? In this case, he set himself on fire, and his cousins and his friends and onlookers and so on, they filmed him on their phones. And they posted that on YouTube and Twitter and chat rooms and everything. But that event sparked what eventually ended up being the overthrow of Ben Ali in Tunisia, and sparked even further outrage in other parts of the Arabic region, and the government in Egypt got overthrown, the government in Libya got overthrown. So this caused a massive ripple effect from that one event. So the point of that is we live in an environment today that, partly because of technology, is far more complex than any of the environments previous to that. When we say the business has to change, the business has to keep up with technology. We talk about microservices and SaaS and cloud and all this stuff. Yeah, they have to keep up with technology, but they have to keep up with the changing business landscapes, and those are far more complex than they ever were. Now, there's a difference between simple mechanisms, like a light switch is simple. We understand there's that's simple, turn it on or off. There's a difference between simple and there's a difference between complicated. Complicated, like a car engine, has a bunch of moving parts, and you can deconstruct it and sort of understand it. There's there's well-known inputs, and the output is the car engine. But in a complex environment, it's far more unpredictable, and environments like the stock market or the financial markets or open source markets or companies, businesses, how we interact, so how startups pop up out of nowhere, and the ramifications of those different events, and how they can be triggered and could be a massive impact or no impact at all. The unpredictability about it is you can't know it in advance. It's very difficult to predict what's going to happen, have a strategy to deal with it, because it's so complex. So how do we deal with complexity in general, right? How do we deal with complex environments? Well, let's fast forward real quick to what we think, we're talking about microservices and some of the goals of what microservices are, and maybe that provides some kind of a solution. When we look at stuff like microservices, we talk about increased interoperability, integration, getting systems to talk to each other, getting them to share data, expose APIs, and so on. We want to derive more value from these systems. Vendor diversity, right? We want to be able to use whatever technology we think is appropriate to solve that problem. Focus on standards and diversification and all that. Federation, getting things to look and feel like they're one, but they're all individually autonomous. They can change individually and so on. Now, this should give us increased business and technology alignment, focusing on the domain, focusing on mapping the models between technology and business and so on. So these all sound really good, right? Increased return on investment. Position IT services or constructs as assets that can be reused. And this should give us increased organization agility, right? Treating IT as the bottleneck, or viewing IT as the bottleneck, focusing on reuse. Sort of like building out pieces to a car or to a machine, where you have these pieces, you assemble them. Oh, but if we want to reassemble them a different way, well, then we'll just take these pieces and reassemble them a different way. Well, that's what Solo was. One second. So we have we come full circle, I guess? I mean, this is the same thing that we were talking about when we were describing SOA, and how you do SOA and how that's going to bring all these benefits to you, but we're still kind of in the same place. So what's different? To deal with complexity, the type of complexity that I described, we need to build systems that are flexible, right? Because if you can't predict what the what's going to happen, you have all this information, right? We have big data, we have mobile, and we have all this technology. We can track and build up more and more data, but we still have the more technology and more data have, the less predictable things are. So if we can't predict what's going to happen, How do we deal with that? We have to be flexible. We have to be adaptable. We have to change. Except we're, in my opinion, using old premises. We're dealing with complexity the same way we've been dealing with conventional, complicated systems. We're dealing with it that way when really we should be looking at it a little bit differently. The old premises that we're using are a little bit at odds with trying to build out flexible systems. And going back real quick to the what ends up being talked about in terms of SOA, and the goal of SOA is software reuse, replaceable cogs, different pieces, so that we can build systems. And well, if we need to rebuild systems, we have all the pieces, right? But it almost never works like that. Okay, we're about to get controversial here. We need to build systems for flexibility, not just efficiency. For the last 130 years or 20 years, we've been building everything from the way we organize our businesses to the way we think about anything in our daily lives, about how to be super efficient about it. But in a complex environment, a train has a rail, has a fixed direction. It's very efficient at getting from A to B. But if all of a sudden, there's a roadblock in the train can't just go around it. The train can't be flexible. It can't adapt to whatever its environment is. Cars do have that option. But we've been looking at building our, I'll jump back into specifically our organizations, our companies, our businesses, with the concern of being super, super efficient. Maximize efficiency, reduce variability. Known inputs and known outputs. And this worked great when we were building products and cars, so like cars or microwaves or phones or whatever. This works great because you have a set known of inputs and you expect a certain output. But in today's reality, whether or not you're building the right product can change overnight. A lot of value from the new startups are coming more from customer service and customer experience than they are the actual product that's being delivered. The iPhone that you get is just a piece of hardware, but those different services that you can consume and the experience that you can get in terms of, let's say, Uber. Uber doesn't own any cars, doesn't make any cars, but that customer experience is disrupting the cab industry. So we've been thinking this whole time about how do we be super efficient, optimize the inputs, predict where we're going to go with what we have, so that we can have repeatable processes. But in effect, that's really like building a machine. A machine is sort of built to do one thing, and you try to change what it's doing, that's kind of hard because it's not what it was intended to do. And to that effect, the way we organize our systems to make them super efficient is to break them down into small individual pieces. And we say, okay, now in terms of IT, you guys or girls are the DBAs, and you guys are the QA testers, and you are the developers, and that's all you guys do. Now, when you start to carve out these little boxes to be efficient, you're going to get that, but you're also going to get inflexibility. You're going to get the smaller that you make these pieces, the more communication, the more synchronization that you have to have between each one of these groups. And you start to build potentially these long, very complex chains of dependencies and interactions that, one chain breaks. Developer puts there's a bug inside the code. It's already made it a week into the development pipeline, and one chain breaks, and now that holds everything up. And furthermore, the more you carve up people and take people away from the responsibilities of their actions, the more they're removed from the reason why you're doing any of this stuff anyway. So developers don't, they have, it feels like where I've seen at large companies, they have very little interaction with what the business actually does. The customer-facing stuff, they're far removed from what that purpose is. So optimizing for efficiency and building our organizations and the way we structure our teams for efficiency reduces flexibility. James talked about in terms of microservices. Microservices is an approach, but it's also, it's an approach, it's a technical approach, but it's also an organizational approach. At unnamed company where I work, I got to see this firsthand. I didn't realize it at the time. I was more interested in the technology that they had. But looking back on it, that is what allowed them to be flexible, the way they organize their teams. So we do want, who's heard of Conway's Law? Conway's Law is something to the effect of when you build systems, you build them and they end up looking like the communication patterns or structures that you have in your organization. So we do want that, right? But we don't want inflexible organizations, and we don't want inflexible systems. We want systems that are able to adapt to these complex environments and make changes without rigid dependencies that force them to synchronize and dependency chains that ripple, the ripple effect, which causes other changes and so on. Because we want to be able to make changes quick. We want to be able to experiment. All the things that we're talking about today in terms of why microservices are so awesome, independently deployable, independently testable, choose the right technology for the right problem. But we want to get feedback fast. We want to put things into production quick and iterate on them so we can learn and adapt. So how do we build flexibility into these systems? Okay, this is not new, right? Dependencies. Dependencies are the key. When you talk about offhand, microservices are supposed to be independently deployable. Just because you make them an individual process, just because you put them into a Docker container, just because you put them into a Spring Boot container or whatever, that doesn't mean your change to that service doesn't impact the downstream services, right? The change that you make or the change that another service makes might actually impact you directly. So dependencies are the key, and I'm sorry to be so underwhelming, but microservices are still distributed systems. There's nothing magical about them. It's a different approach. The technology around it is really cool. These are still distributed systems. So, as a definition to go on when we look at the examples here, microservices are they're autonomous. Okay, they can make changes when they want. That's the idea. We want to decouple changes that I have to make from microservice A from microservice B. They're easy to understand individually. We do this for scalability. Not everyone's going to have an internet unicorn scalability problem, but still some of the other benefits of this approach might still serve a purpose for you. So, have their own life cycle, should not impact, So another part of building these systems is that since we can't predict what's going to happen, both in terms of the business landscape and in terms of what failures might happen in our distributed system, because we know failures do happen in distributed systems, we shouldn't be building them such that they're big and robust, such that we can withstand this one problem or these three problems. Right, we want to build systems that if they do have failures, they don't completely collapse. Those failures don't cascade. That in fact the opposite is true. If a system goes down, ideally the system reorganizes itself in such a way, or it has a certain knowledge of the environment to be able to continue to process maybe some degraded functionality, but it doesn't just completely wipe everything out. So, in my opinion, microservices is, there's a lot of cool technology, right? We know that. But it's organizational structure, how your teams are organized, how they interact with each other. James earlier talked about having teams, small teams, right? The more people you add to a team, the more complex the communication becomes between that team. So, you look at teams like the ones that, any small adaptable agile team, like the Navy SEALs come into mind. They're incredibly adaptable, land, sea, and air. But there's only 4 or 5 per team. In this particular internet unicorn, about 5, 6. So the two pizza rule type mantra. But so organizational structure, having ops and devs and QA and everybody on the same page with the same purpose, aligned. But then we also have to look at a couple of other facts that may not be technology driven either. Understanding what it is that you're going to build and how that maps into technology. The concepts from domain-driven design are very, very important here. We can't, as a developer myself, I can honestly admit that I'm not terribly interested in how a bank works or how a retail outlet might take standard order to cash or whatever. I'm more interested in the technology. That's why we're all here. But understanding the deep semantic differences and ambiguities that happen in these complex domains is very important to building out microservices. You have to figure out where the boundaries are and what models go together and write APIs and modularity and all that. And then we're building distributed systems. There's nothing new about that. There are well-known, tried and true practices and patterns that we can apply here. We don't have to rip everything out and say, okay, well, now we have to have fancy service discovery. Now we have to have fancy immutable infrastructure, which are all good things and solve hard problems, but those themselves are not prerequisites to microservices. So we talked about organization, building teams that are aligned on purpose, right? That are small, can communicate, can iterate, are very close to what customer-facing problems are, so that they can make decisions autonomously, right? So that's another part of the microservice prerequisite, or what we're trying to achieve is autonomy. But if services are autonomous, then that's good. We want to be able to change them. But individual teams who own those services, without having to talk to 10 other teams to make a change, that's what we want. Transparency, everything. So open source is a fantastic example of what this sort of organization looks like in practice. And in open source, at least in the Apache communities, if it didn't happen on the mailing list, then it never happened. So sharing your updates, sharing your interactions. Have you guys heard of things like River or Slack or HipChat or using those tools by themselves isn't the requirement here, but keeping all of your exchanges and your interactions and so on in those tools, taking advantage of something called chat ops. Who's heard of chat ops? Where you're actually automating systems from within the chat environment so that people on your team don't have to synchronize with you and communicate with you all the time when they have to figure out, well, how do we actually do this deployment? It's right there in the chat window. They just typed it out, and a bot saw that and went off and did it. So there's a lot of these, you look at different systems like open source that have a lot of these sort of platforms, or I don't want to call it governance because that's what the SOA, but there's a lot of this stuff that kind of is a prerequisite to organizing your teams a certain way. Yes? Okay, so the overarching theme that I'm going to be driving here between these different points is, how those dependencies, how those synchronization points are going to keep you potentially from doing some of the stuff that everybody talks about with microservices, right? Because we can all take our apps right now and deploy them into a single process, or deploy them into no JVM. That alone isn't going to get you anything. The whole point is the adaptability, the flexibility, the scalability, and all that. And that's not just a technology problem. That is an organization problem. So the point here is really keeping the fact that it's the dependencies, the synchronization points that you just described, that are going to keep you from doing this sort of architecture, in my opinion. Because on the other hand, like I said, I work very closely with this organization. Netflix is very famous for, how are they organized? Adrian Cockcroft says, we don't know. We don't really care. We're an emergent. Our organization is continually evolving. And same with a few other places that are successful at microservices. So the real success story of microservices isn't these fancy new technologies. It's the way that these organizations have been able to re-architect themselves in such a way and be very successful and not have it turn into chaos, right?
But you're still facing a major complexity problem when I look at the microservices technology. You go back to the old world of SOA. There's no technology solution that will rewrite a SOA paradigm, a architectural paradigm, and provide an infrastructure for it. So in a sense, now you're taking, especially if you put up domain-driven design, you're going to the domain-driven design, you're looking at your business case and your business use cases and drill those down into microservices. So what I'm really looking forward to see is what vendor solution or what type of technology Red Hat or any vendor is going to provide to let me take these domain-driven designs, boil them down into microservices based on my business use cases, and then solidify that in a concept of an orchestration to solve the dependencies. That's the tool I'm looking for.
Yeah, and like I said at the beginning of the talk, we talked, in the morning. We'll talk in the afternoon more about technology-specific stuff. But the point of this talk was when I'm going out talking to customers and they say to me, "How will microservices help me?" My answer is going to be, "You're asking the wrong question." Right? But that doesn't mean that you can't build, these distributed systems. That doesn't mean that if you have these tools that you can't be somewhat successful doing things differently. I think microservices for enterprises might look totally different than, we might have to call it something else, but different than what Netflix and Guilt and all these other. Right. Yep. But Kubernetes is awesome. Docker is awesome. Wildfly Swarm, which we're going to talk about, is awesome. I mean, there's a lot of really cool technologies that are coming out to help enable this sort of development paradigm or this way or architectural paradigm. But I guess my point is it's not, if you look at it just as at the technology standpoint, that's you're not getting the whole picture. How much time do we have? About 5 minutes, 10 minutes? 5 minutes. Okay, so we talked about the three sort of forces that you have to balance, right? It's not just technology, it's organization, it's understanding the domain. But at the end of all this, it's how these different dependencies are created and managed and manifest, or even unseen or invisible dependencies, regardless of which layer you were looking at. Whether it's organization, okay, now you're talking about teams and their dependencies. When it's domain-driven design, it's the semantic difference between in a warehouse management system where you have parts. What does that mean? For a warehouse management system, parts may mean a classification of a type of part, a kind of part. But in a quality assurance application, a part might actually mean a very specific part, not just its classification. So being able to disaggregate and remove ambiguity in terms of contexts, in terms of models, and those dependencies between the models. So it's just, so when we look at SOA, and probably stealing a slide from a future slide, but when we looked at SOA, we talked about, well, it's just services. Services all the way down, turtles all the way down. But really, it's dependencies all the way down. And the farther and the deeper those dependencies go, the more rigid and inflexible your systems are going to be. So in terms of adopting microservices, the complexity in the technology, the technological space itself is there. There's no question about it. You start to break things down into smaller pieces. You have to manage more things and think about the interaction between more things, logging and metrics, and how do you automate your build pipelines, and service recovery, and all this stuff becomes far more complex. When you're, the canonical thinking is, well, each microservice owns its own data. It's autonomous, so it should be able to change its schema without impacting everybody else. But what happens when you have large orchestrated transactions? When to use it? Maybe microservices isn't the right solution. In high-performant, as an example, in high-performant financial systems, high-performance computing, microservices might not be the right solution for that. The organizational mismatch, which, like I said, that is very pronounced in a lot of these big organizations. And so how you overcome that, whether it's, I've seen teams at big banks that were traditionally top-down command control, spin off small teams and organize themselves in sort of open source fashion. And those teams were very successful. Monitoring, logging, all that stuff, just sticking with monoliths. I got 3 minutes. So let's look at a quick, simple case study. The case study that I'm gonna demonstrate illustrates from a distributed system standpoint and how that aligns with the rest of your, if you have your teams organized a certain way, what that could look like. This isn't a recipe. I mean, you don't just see one system and say, okay, now all my systems need to look like this. You choose the right tools for the job, but this is a typical architecture, a typical pattern that I would see that could be solved this way. So if you look at maybe a retail shop where you have sales and you have billing and fulfillment and marketing, you have all these different groups or these different business lines of business or areas of the business. And you look at how do you implement this in microservices or SOA or whatever whatever you want to call it. In the SOA world, let's be really efficient and focus on reuse and have all these little entity services, right, so that we can just reuse them. And then we'll have this layer of activity services on top of it. And then on top of that, we need process services and all this complicated infrastructure that big proprietary companies can make a ton of money on. But once you start to break that down, so turtles all the way down, but that ends up not working out always. And so here's a quick example. If I have a website, I'm selling shoes, and I'm trying to check out, and as part of the checkout process, we have to calculate the total cost of whatever's in the, whatever shoes I'm buying. Well, to do that, we need to figure out the taxes. We need to figure out what are the taxes that go along with that. And to figure out the taxes, we kind of have to know where they're shipping to. And then depending on what they're shipping, they might have different taxes for different areas. So we have to call all these services to figure out, and this chain theoretically could be 25 services long, right? All of these are synchronous calls, SOAP, REST, whatever, and they all block. Not in terms of the threading model. Maybe use a reactive programming model, but nevertheless, over the wire, they're still blocking. Now, what happens if if the marketing service goes down? Well, can we calculate the order? Can we calculate the cost of the order? Maybe everything just starts failing. I've seen systems where that happens. What if that's all good? What if now we've built this using great SOA principles and so on, so we have to be, part of that is being agile, right? We should be able to make changes and align with the business and do all this wonderful stuff. Now, if I make a change that says I want to do predictive pricing, I want to know that if a customer is a certain, gold level customer, which is the best, and they bought a certain number of things over a certain period, maybe they get better pricing, discount or something. But to do that, we have to know what the customer bought. And to do that, we end up calling into sales. And you could potentially have these really odd cycles of calls and odd dependencies at runtime that you don't see because you developed all these services with JSON and REST, and they're decoupled, right? All of the runtime, all of the design time coupling stuff, we checked all those boxes. But at runtime, you end up with this vicious loop, and we know that when you end up with loops, especially in distributed systems, things kind of could grind to a halt, which is not as agile as we wanted it to be. So, maybe we explore, well, so if we're talking about complex systems and complex adaptive systems and how you organize each other is kind of like open source, well, how do they interact? How do organisms interact? And the answer for this particular illustration is events. Responding to events, responding to changes in the environment. And in terms of how that applies to technology, as Rob just made it back into the room, messaging to the rescue, right? Because now we can pub/sub events and have different applications react. Like I said, this is not a canonical, everybody must use pub/sub. This is not the point. The point is to illustrate how you build how you achieve some of those principles, some of those ideals with microservices using basic dependency, distributed systems patterns that we've used for quite a while. So in the pub/sub model, maybe instead of calling into these large chains of services, maybe we have the marketing department publish events when customer John is gold. So he bought enough stuff or whatever the requirement was, flew enough miles, now this customer is gold. Now we publish that event. And the customer service or the sales service can capture that event and store it in its own database. Right? So now the databases between the two systems are totally decoupled. The data that the sales services are interested in are now stored locally. So when we get a request to do pricing, we already know that John is gold. We don't have to make all these long calls out to other services. Now the sales service owns its own data, is autonomous enough that it can make changes without having to depend on other calls and so on, and can make decisions even if the other services go down. It's autonomous. So I'm running out of time. So the advantages to this are some of the things that I just said. Disadvantages are it is far more complex. What happens when you have transactions, and you can look at things like event sourcing and CQRS and that kind of stuff. Denormalized data. This big company that I was, this microservices company that I was working at, the denormalization of data allowed them to be far more flexible. Normalizing all that data forced them to always go to this one database. And that was a trade-off that they were willing to take, and I'm very successful for doing that. In part, but for doing that. Is that it? That's it. We'll get beer afterwards. All right. Thank you.